All right, Math 2, here we go. We got lesson 4.2.4, Trigonometric Applications. Trigonometry is just the study of right triangles, so that's why that trig word keeps on showing up, because we've been doing right triangles. Sorry, my voice, stupid kids got me a little sick. Anyways, David and Emily are climbing El Capitan in Yosemite National Park. David's on the ground holding the rope. There he is. Attached to a carabiner, or the carabiner, I don't know, above Emily as she climbs. Emily stops to rest. David wonders how high she has climbed. The rope is attached to David's waist, 3 feet off the ground. His waist is 3 feet off the ground? That seems kind of high. Anyways, and he lets out 48 feet of rope. The rope makes a 55-degree angle with the ground, and he's standing 20 feet away from the base wall. That's a lot of information. All right, so we should make a picture here so we can kind of see what's happening there. There she is. She's climbing, blah, blah, blah. So we got David. Hey. So he's sitting here around his waist. He's got the rope. It's going up. It's attaching to Emily. Hey, don't drop me. So she's up there. So this is the angle that they're talking about, that this is a 55-degree angle. All right, and we know that David's from here to here, this is 3 feet off the ground right there, from there to there. Okay, so what else? He's 20 feet away from the base of the wall, so she's climbing up this wall over here, and he is from here to here, 20 feet away. All right, I think we got a lot of information there. All right. He's let out 48 feet of rope. Oh, that's interesting. So he's let out 48 feet of rope. So this is 48 feet right here. Okay. So he's let out 48 feet. There we go. Is that right? Or is 48 feet here and here? Actually, I think it's that. So like this portion and this portion would be the 48 feet. Let's get rid of that for right now. All right. Assuming that the rope is taut, approximately how long is the rope to the carabiner? Okay, so yeah, we weren't right. So here we've got the total rope is 48, and we want to know how long this section of rope is. That's going to be our X right there. Okay. So now we can go ahead and solve for that. I got 55 degrees here. This part right here is the adjacent. And this is the hypotenuse. All right. So here we can find out X. So we're going to do since it's adjacent and hypotenuse, we can say the cosine of 55 degrees is equal to adjacent over hypotenuse. So that's going to be 20 over X. And so when the X is in the denominator, we can exchange the extremes right here. We get X is equal to 20 over cosine 55. All right, so let's break out the calculator. 20 divided by cosine of 55 comes out to 34.86. Let's call that 34.9-ish. All right, so we're going to call that 34.9 right there. Okay, so remember, that's this section of rope right there. But we were talking about before that the rope that's been let out is 48 feet. So that's this section plus this section should be 48. So if I take this and subtract it from 48, that's how far this section is from the carabiner up here down to Emily down there. So I'm going to say it's going to be 48 minus 34.9. What's that, 11.1? No, 13.1. So it's 48 minus 34.9. Yeah, 13.1. What was I thinking? So it's about 13.1. So it looks like this section over here is 13.1. This section right here of the rope was 34.9. All right. Next, how high up the rock wall has Emily climbed? Now, this is interesting. So we know that she's climbed this 3 feet right here, because that's from the floor to this part right here. We can find this section here, but she hasn't climbed up all that section yet. So what we should do is we should find this y value, which is all of this, add the 3 feet, and then take away the 13.1 feet. And that should be what we've got there. So what I'm saying is let's find y. So we're going to do the tangent, because we've got opposite over adjacent. So the tangent of 55, that's going to be y over 20. So we can just multiply both sides by 20. So y is equal to 20 tangent of 55. So 20 tangent 55 comes out to 28 we'll call it 28.6. So it's about 28.6 feet. Now remember, that is this entire section here. But remember, part of the rope is right here, so she's not a total of this much. So we would take 28.6 plus this 3 feet, and then take away this 13.1 feet of rope that we have there. So we're going to take that plus 3 feet, and then subtract 13.1. So it should come out to what? 18.5. So we got 28.6 plus 3 minus 13.1. Yeah, 18.5. So she is 18.5 feet off the ground. All right, the Bungling Brothers Circus is in town, and you're a part of the crew that is setting up the enormous tent. The center pole that holds up the tent is 70 feet tall. To keep it upright, a support cable needs to be attached to the top of the pole so that the cable forms a 60-degree angle with the ground. All right, so here we've got the pole in the middle. We've got a support. Was that rope? A cable. So there's a support cable. It's attached to the ground to hold it up there. This is 60 degrees, and this was 70 feet tall. So how long is the cable? That would be this section here. So we've got opposite and we've got hypotenuse. Opposite and hypotenuse is sine. So we're going to do the sine of 60 degrees is equal to the opposite of 70 over the hypotenuse x. So exchange the extremes. X equals 70 over sine of 60. And we plug it in. 70 divided by the sine of 60. 80.2 is what we're going to call it. So the height of the pole is about 80.2 feet. All right, so this section here is about 80.2 feet. How far from the pole should the cable be attached to the ground? So that's this part. So from the ground to the pole, how far is that? Well, now you're going to use tangent because we've got opposite and we've got adjacent. We don't want to use the 80.2 because that's a rounded number. You want to use exact numbers when you're entering in new equations. So we're going to do the tangent of 60 degrees is equal to 70 over y. Exchange the extremes since the variable's in the denominator, and we would get 70 over tangent of 60. And that comes out to approximately 70 divided by tangent 60. 40.4-ish, right? So it's about 40.4 feet there. Awesome. Last problem. Nathan is standing in a meadow exactly 185 feet from the base of El Capitan. At 11 a.m., he observes Emily climbing up the wall and determines that his angle of sight up to Emily is about 10 degrees. Okay, so here's the wall of El Capitan. Here's Nathan. Oops. I gave Nathan two heads. He's got a backpack on, that's what it is. All right, so there's Nathan. He's 185 feet away. And he looks up, and there's Emily hanging on for dear life up on the wall. So he's looking up at 10 degrees. It says that it's 11 a.m. Okay, so this says his eyes are 6 feet off the ground. So that means this part is 6 feet. How high is Emily at 11? So this is x. So Emily is going to be x plus 6 feet. And we've got opposite and adjacent, so we can use tangent there. So do the tangent of 10 degrees is equal to x over 185. So this one we can multiply both sides by 185. X is going to be equal to 185 times the tangent of 10. Let's plug that in our calculator. 185 tangent of 10 comes out to 32.6. So it's 32.6 plus the 6 feet for his eye, where his eyes are. So 32.6 plus 6, she is 38.6 feet high. All right, at 11:30, Emily has climbed some more, and Nathan's angle of sight to her is now 25 degrees. All right, so now the angle of sight here is 15 degrees more. So we're going to do the same thing, except now we're going to do the tangent of 25 degrees equals x over 185. Now notice here it says, how far has Emily climbed in the past 30 minutes? So we only want this section. So what we're going to do is we're going to solve for this whole section right here. And then we're going to subtract out this section right there. So let's call this y instead. So let's change that to a y. So if we just want to find out how much she's increased here, what we can do is find this entire section here and then subtract the x. And that should say how much she's grown up there, or how much she's gone farther. So we get y equals 185 times the tangent of 25. 185 tangent 25. 86.3. So this comes out to about 86.3. All right, and then on the previous problem, it was right here. This distance here was 32.6. So if I take 86.3 and subtract out this little section right there, that should give me how much more she's climbed in that half hour. All right, so 86.3, and then we're going to subtract out 32.6. Looks like she's climbed 53.7 feet in that last half hour. All right, if Emily climbs 32 feet higher in 10 more minutes, what will be the angle that Nathan will have to look at in order to see her? Okay, so now we're saying this. So we already know that she has climbed the 86.3. She's going to climb 32 more feet. Now, this is still 185 feet away. What we're looking for now is the angle that she's looking at. So I'll put theta right there. Okay, so this whole section here should be a total of 118.3. So now I'm looking at the tangent of theta is equal to, opposite is 118.3 divided by the adjacent 185. So when we're looking for the tangent, or when we're looking for the angle, we're going to have to get tangent away from here. So we use the inverse of tangent. And theta is going to be equal to the inverse of tangent of 118.3 divided by 185. All right, so inverse tangent, it's right up above the tangent button there. It says tan negative 1. So we need to hit the second button first up here. So second, you can see it says second up there. So second tangent, and we want to do 118.3 divided by 185. So 118.3 divided by 185. It looks like now they're looking at a 32.6 degree angle. So that angle is about 32.6. Which makes sense because we were at a 10 degree angle, then a 25 degree angle, and now we've climbed even higher, and now we're at a 32.6 degree angle. So makes sense. There we go. That is all you got for Unit 4. We are done. I'll see you back when we start Unit 5. Bye-bye.